Alright, Internet. You may wonder, why isn't there a fuzzy circle around me? Or you may not even notice. But I'm gonna switch it up on you. We're gonna have hard edges today. We might have colorful edges tomorrow. So today's challenge is like a walk in the park in comparison to the 28. Honestly, I hope to God, 30 through 34 are not as hard as 28. 29 was difficult. I couldn't solve it myself, as per usual. But as I mentioned, it's not for me to come in here and actually hack all this stuff away. The purpose of all this stuff is basically for me to learn as much as possible and really understand more about different types of exploits. And it's a learning journey. Eventually, if I do this for 10 years straight, I'll get good at it. Eventually, I'll start to see patterns like humans do. Anywho, let's get on to Natas 29. So the 29th, we got some gobbledygook here, talking about, hey kids, you remember Pearl Writ, right? Want to go a doodle, rat up, read up, Want to go at the cool. Old school. Want to go old school, read up. Okay, old school, that's what it says. It's interesting how we can actually read stuff like that. It's crazy. And then you can see there is no special sauce once again. So we have no source code. We have some gobbledygook here. We have a dropdown. And this dropdown has some options, which are Perl Underground. So I decided to Google Perl Underground, see what it was. Mostly when you actually Google Perl Underground, it comes up with a whole bunch of Pokemon stuff. Apparently, there's a Pokemon that this one here is an underground arena. And there's some Pokemon stuff going on here. And I think this little guy here is one of the Pokemon. What's his name? Diglett. Diglett. All right, so that has nothing to do with the challenge, but I wanted to show it to you. And this is, I think, what they're referring to, because obviously this is in relation to the 4, 5, and 2, because if you go down here, you can see 4, 5, and 2. So you can see Underground 1, I'm assuming, and then that's through 5. You come in here, you can see this is one of the references to Pearl Underground, and then if you actually just, look that up, it's going to give you 1, 2, 3. For some reason, DuckDuckGo is way better than Google when it comes to that stuff. But anyways, you can see it's a huge text form, and I think what these were basically, they were submitted every couple of years, I'm assuming, and it's a way for them to basically improve Perl and talk about the improvements on Perl and how you can improve its security. It's kind of a riff on all the different exploits for Perl during that period in time. I'm not sure if there's a date in here. I'm sure there probably is a date, but Control Find doesn't want to work for me. 2006, there you go, date. So you can see that these are a little outdated, so there's a lot of weaknesses being discussed here. And when you open that up here and you open up these drop downs, it's going to basically give you that text inside of the screen, green and black, matrix style. And you open these up and it shows you the 3rd, the 4th, the 5th, etc. That was the 3rd, we redid that. We could do the 5th. And it's just a huge page of text talking through tons of exploits and how, like, the different weaknesses in Perl and things like that. But there's nothing that is super useful here because I think it's just basically a discussion forum of people talking about exploits in Perl. But when selecting these, one thing we do see is up at the top here that there is a change in the URL. And that change in the URL is something that I've learned through this process. And it's something that hopefully we'll see more patterns in the future of, not just this, but other things. But anytime there's a question mark, we know there's some sort of command going into this this kind of, I think this is as code source because it's .pl, which is Perl. And we have a question mark, so that's some sort of command, right? We're giving a question mark or a question query into it. And then we have file equals, so that means that we're gonna basically put some sort of parameter in here. That parameter is then gonna be piped into file, and then once it's piped into file, that's gonna do something. So I'm assuming there's some sort of injection process here that needs to be done. I didn't know that first off. I had to research and read more about it. But actually, let me take a step back. I forgot. We have a process. We have a process here, people. So the first thing I'm going to show you a few solutions that I read through that I thought were useful or listened to. Chris Dale did a good job again. He does a lot of discovery in the beginning, and he actually got hooked up on this as well because he's not much of a Perl fanatic like most people. He's more in PHP and other things. But he does a good job at discovery, of course. Surprisingly, John Hammond actually didn't do one for this, so I didn't have a video for him. You can see that actually this website is pretty great. I love the way I love the design, first off. And they did a pretty good explanation. They walked you through kind of how they solved the problem. Really, I just want to show you the design. I think it's pretty amazing. So they basically have all of the Wargame solutions here, and you can see it's kind of all centered, nice and bubbly. Not really has nothing to do with the challenge, but I thought it was a great design, and I wanted to share it with you. So their explanation was good, but didn't go into too much detail. This explanation was pretty solid as well. They have all the Natas solutions too. They explain a lot of what they're doing. They actually solve it in a different way. So there's two ways of solving this, so I'll show you both. But this was an interesting way as well. I enjoyed that. And that is it. I'll jump into other things when it's relevant. So specifically here, so we know that there's some sort of injection that we have to do here, and it's associated to Perl. So I just started Googling Perl injections and things like that. And also following along with the solutions. And if you look at the solutions, they actually kind of toy around with this and trying to figure out different ways to inject things into this equals file piece. So if we try to do it index.pl, it gives us nothing back because we're trying to search in the source code and it doesn't allow us to do so. So then what everyone else did is they just did a whole bunch of fuzzing through burp. And when you do the fuzzing, you start to realize that one of the items that it allows you to fuzz is a pipe. So when there's basically a file equals, and then there's a pipe here, that pipe allows you to actually inject a command into this file here. So you can actually put in something here, such as like, I want you to cat out, X, Y, Z. And once it cats that out, it's going to then print that onto the screen. So with this, we can actually do that here. So if we do a pipe, and you can see some of the answers I put out here, the first thing we can do actually is we can just do an ls and see what that brings back. So if you do an ls, and then actually one thing I'll point out here is you see that there's a %00. For some reason, you have to put a null byte after the command, so it actually executes that. I didn't find the reasoning why behind that was the case. I couldn't come across anything in the PHP or the Perl documentation or anything like that, because if I come in here and type null, there's nothing explained. And I couldn't find anything else on anybody else, but I've seen the solutions and everybody else included null inside of their solution, and they didn't provide why, but that's the case. So when you do an ls, you can see that we're printing out the different files inside of the directory. So we have a few different files here being listed out. You can see them somewhat separated by the space. So we have underground, so Perl Underground 4, Perl Underground 3, Perl Underground 2, 5. We have Perl Underground text as 1. And then we have our index.pl temple and index.pl that we see up here. And then we also have index.html. So we can actually print this index source code out by including it up here. So if we do ls pipe and then we do cat, and then we're going to basically, all caps, good, all caps cat, because we're hardcore right now. We want everybody to know how excited we are. Cat, no, not caps lock. Take the caps lock off. All right, cat. And we're going to do plus because it's URL encoded. We're going to do index.pl here, and then we're going to include our null byte here. Push enter there, and it's going to give us some gobbledygook, and it's going to really mess up the screen. But if you actually read through this, you can see there is some source code here. And the source code really that we want to look at is sitting right here. And instead of looking at it in this screen, what I'm going to do actually is I'm going to show you one of the solutions, because they just pulled out the source code and made it more readable. So instead of me doing it, I'm lazy and I'll just look at theirs. So I think it's one more. Of course, it's the one that does the beautiful text. Here we go. So here we go. This is the source code bit that I'm going to talk you through. That is what we're seeing here. So what we're seeing here is basically beautified here, so we can see it in a different format. And that's the source code that we've just printed off on the file, because we played with the URL encoding here to actually print that out. So if I come here and change the colors, I'm going to walk you through some of this stuff here. So when you look at this, there's a few things that potentially could jump out if you've seen Perl before. I mean, first things first, without even knowing Perl, you can see that it's basically an if condition. So we have a condition statement here, and we have a series of things that are happening. So first we're going to take the input. So that input is from what we're giving it. So we're going to input our choice. So we have, the parameter files that you choose, and that incorporates it into the equal sign up here, right? when you do that, and this is obviously not the correct URL, but imagine this is the correct URL, and we're inputting that choice there, so that's going to be underground 5, 4, 3, 2, 1, and then basically it's saying that if this is true, so if there's a choice that's made, I want you to shove that into this variable, and then basically if there's, in this variable that you're shoving in here, the data you're putting in here, if Natas is a part of that string, then I want you to print out meep. So that's basically us trying to print out Natas, because we know that it's under etc/Natas_webpass/Natas30. And that's because that's where it's been for all the other challenges. So if we put in Natas, it's going to print out meep anytime, because it's doing a regular expression search here. And the reason I know that is because I Googled it, and basically there was a Stack Overflow explanation that stated that with Perl, if there is a squiggly thingy before it, it's basically doing a regex, and it's looking for whatever text is after that. And if that text is inside of there, then it's going to print meep. And if Natas isn't in there, then what we want to do is we want to do this open function. And this is where the exploit comes into play, and this is what I did a lot of reading into. So this open function here basically stating that we have fd, which is our variable. I think it's something file handle. I'll show you what it looks like. And then there's is this like an acronym for expr, which is basically the file that we're reading or writing into. In this case, we're doing, I think it has the ability to do both, because there's no additional items before this, which I'll explain in a second. So we have that happening, and then it's going to print pre afterwards. And then while this is the case, then it's going to print, it's going to run through the CGI text here, and then it's going to do an escape HTML, which is alternative solution. So this escape function here is one solution, and then we can also do another solution with a command injection wildcard. That's what it's called, wildcard, which I'll show you as well. So this is the code we see, and this is what we're playing around with. So let me jump into some of the bits that I walked through. So actually, let me show you what Natas looks like first. So this Natas piece. So if we come in here and we type in, let's have the pipe as is, and let's just say cat Natas. It comes back with meep. Or if we just do, it could be anything, ls Natas with no space or anything else. So anytime Natas is in there, so you could literally put anything here, and then you could put anything here, and it's still going to read Natas inside of this text here, and then it's going to do the regex max, and it's going to print out meep. So we can't have Natas in there. We have to figure out a way to trick the system to think that we're saying something else, but we're actually saying Natas. That's the first thing. And if we jump through here, the next thing I wanted to show you is the open function itself. So this is the Perl, I don't know if this is the Perl official website, but basically they talk to you through the open function, what it does and how it exists and its purpose. And you can see with the open function, there's different arguments you can put in there. So you can put in up to, I think, 4 arguments. So we have file handle, mode, expr, and list. And then we have 3 arguments, 2, and 1. And basically when reading through this, there's a specific point that it mentions kind of what this is doing. Like I said, the premise of this function is basically to open a file, read and write into it, or append to it. And when reading and writing and appending to it, you can see that there's arguments you can put prior to it. So these 2 dashes is appending. So we want to basically append whatever we're pulling from this into this. There's other ones such as, I think this is read and write. So you can see reading and writing. So we're going to read and write into this file. And there's like multiple things you can put prior to the actual file that you're writing to or reading to. And that was the mistake that the developers made here. When you look at the source code, you can see that there's only 2 arguments inside of here instead of 3. And they didn't specify if it's a read or a write. And that leaves it open to an exploit of a command injection. And I think there's nothing else in here I wanted to share with you, but there are 2 other pieces I found that were quite useful. So this PDF here from WISC.edu, they talk through a variety of command injections, but one is actually in Perl, so that's good for us. And you can read through this bit talking about the importance of not using 2 arguments within Perl. So the safe thing to do, and I have it noted, I don't want to show you that browser. I have it noted in here, where basically within Perl, the best way to approach this is to ensure that you have more than 2 arguments. So if you're ever using the open function, you should always use two arguments specifying the type of read and write here. And you can see another mention here is basically the really easy way to fix this exploit or vulnerability is just to include the caret prior, or the greater than or less than sign prior, to state what you're doing, so it actually doesn't allow that person to put a command injection in there. So that was one interesting thing. Another bit here, so they talk about the two arguments, don't use it, bad idea. They talk about different methods of actually using the pipe itself to actually run that function inside of that URL location, so we can get it to do something on our behalf. So that's it for that one. This one explains something very similar. Let me make this bigger so you can see it. What if I can make this go away? Oh no! Okay. So here they basically state the same thing I just mentioned. So you can see this is using two arguments. The attacker can instead provide a shell command, which is executed by the program, and they basically show you an example of the no and why you shouldn't do it. And then they walk through basically how you can fix that by including the greater than or less than side behind that item, so it lets it know that it's running some sort of read or write, and it doesn't allow them to do the command injection. So that is what we're trying to achieve, and that is the weakness in the open function that we're looking at here. So when we see that here, that's something that you would know if you were a Perl guru and you knew all this stuff, but if you read about it, then you learn about it. Okay, so if that's the case, then we're going to show you the solution. So we've kind of walked you through different bits and pieces. I'm going to show you two solutions, one that's based on URL encoding, and the other one is based on wildcards within command line. So let's show you the first, which is, let me go to the one that I have saved. And this is not the one I wanted to show you. Sorry about that, internet. I have two here that I want to share with you. So the answers, okay, here we go. I got two answers here for you. And I'll walk through the answer, then I'll put it in. So first we'll do the command injection one, which was the most straightforward and made the most sense to me, which is we're leveraging this thing called a wildcard. And actually, let me show you what a wildcard looks like, because I had to Google that as well. So in here, they basically talk you through the different types of wildcards within command. So we have an asterisk wildcard, and then we have also a question mark wildcard. So an asterisk wildcard is basically searching for multiple characters. So you can see here that we're looking for basically enter star cheese. So anything prior to cheese that's included there. So string cheese, Swiss cheese, sliced cheese, all those are going to be included in your search. So if you're doing some sort of grep on the command line or a cat, it's going to pull all that out because it's searching for all the characters before or after a certain line. Same thing applies for here. So if we're doing a dir old, it's going to pull everything out with a .old on it, and the same thing for ls. But for a question mark, it's actually looking for a specific character. So not for a list of characters, but only one unknown character. You can see there it's mentioned. So here we're looking for take question mark text. So it's going to be take 1 and 2. So it's going to look for that specific character that's missing. That's the wildcard. And it looks like you can add multiple as well, which is nice. So that is a wildcard, and that's how they function, and that's what we're going to leverage here, because what we're going to do is we're going to remove the T in Natas or whatever else. Yeah, probably the T is the easiest one. To remove the T in Natas so that we can actually trick the regex that the coder has put in, so we can kind of skip over that. So here you can see we have Natas, so we're going to replace Natas with a question mark. We could also do the asterisk as well. Either one will work. And then here what we're going to do is, I've mentioned here, so you can replace it with the star, everything I just explained previously. And then our overall solution is going to be this. So we're going to basically state that we're going to do a cat, we're going to do an etc, we're going to have a plus sign obviously in here for the URL encoding. We're going to do this for the T, so it's not read in the regex, and then we're going to do the same thing for this one, so the T is out. And then by doing that, we should get the answer. It should pop out the password. So if I go back here and refresh, and I just put that in there and do a plus. Oh no. Cat plus that. Oops. Bitdefender is like, yo, this isn't cool, man. This page is blocked for your protection because it's sending other stuff towards you. Say, I want to get infected, Natas. So let's refresh that. Here we go, come on. What am I doing wrong, internet? Maybe the null byte. It was a null byte. See? It's always a null byte. So it gives you back the password. Here you go. There's your answer. So that's the command injection with wildcard, and then I'll just copy and paste the other one in here. So the other one is basically taking advantage of the escape HTML function, because apparently one of the answers basically mentioned that when this escape HTML function occurs, if you put in something that has basically a series of quotes, it's going to escape those quotes from there, because you can see basically it's saying it's Natas, but it has quotes around it, so it's going to skip the regex. Reason being is that it's further along in the condition itself. So if we come back here, we can see that our regex is up here, but we're already going to pass that, and we're going to supersede that condition. And then once it gets into the while loop here, the escape is actually going to extract those quotes due to the fact that that's part of what the function does. And you can see basically it's going to take out those quotes there, and then once it takes those out, then we're going to get our answer. And this is basically the URL encoded version of that, because the quotes basically that's a space. So quote is going to be, there we go, %22 is the quote. So if I copy and paste this in there, and you can see they have the null byte here. That's what I was missing last time. So if we copy this and paste it in here, enter, got our password back. So, internet, that was so much easier in 28, or at least easier to understand. I will see you on 30.